Good morning. Welcome to lecture series organized by KSRM College of Engineering, Kadapa. Myself, I am Dr. M. Sreenivasulu, working as a professor in Computer Science and Engineering Department. Today's topic of presentation is congestion control in ATM networks. In this lecture, I will brief about networks, types of networks, ATM networks, congestion in ATM networks. What are the mechanisms to control congestion in ATM networks? Computer network is defined as a collection of independent computers connected by using communication medium. Laptop computers, desktop computers, printers, scanners can be connected by using wide medium or wireless medium, switches, routers, etc. What are the advantages of connecting computers to a network? The advantages are communication, resource sharing, retrieval of remote information. Users can communicate with other users by sending files or mails. Not only users, but also the process running on a machine can send files to other process for communication purpose. Resource sharing is also one of the application of computer network, where the resources such as hardware as well as software resources can be shared by users or processes in the network. So, a hardware resource example for hardware resource is a printer. So, printer can be shared by a number of users at different times. Software resource such as files can be shared by the users. Not only the data files, but also the application software can be shared by a number of users at different times. Retrieval of remote information is another application of a computer network. User can remotely access the files available at a different place. So, coming to the issues in computer networks, security is the main issue. So, several files are available in a computer network. It can be accessed by several users. We have to ensure that only authorized users are allowed to access and edit the file. So, unauthorized users are not allowed to access the files. Traffic management, congestion control are other issues in computer networks. So, coming to types of networks, based on geographical area, the computer networks can be classified into various categories. LAN, local area network, MAN, metropolitan area network, WAN, wide area network. Local area network is a network which consisting of computers spread in small geographical area. Within a building or within a room, the computers will be spread. So, the files can be accessed, so information can be shared in LAN. Metropolitan area network is a network where the computers are spread in a city, that is range is up to 50 kilometers. So, we have a number of LANs at different places. So, we can connect these LANs by using some communication medium and interconnecting devices. Wide area network is another type of network where the computers are spread across states, countries, etc. So, we require interconnecting devices like routers, gateways, etc. to form wide area network. Based on the type of services provided by the networks can be classified into two categories. One is ISDN, Integrated Services Digital Network. So, this network operates at a lower transmission rate, 64 kbps per second. It allows the transmission of text data, audio data, video data, but quality is very less. Coming to other kind of network, broadband ISDN network, it will operate at higher rates. So, that data transmission rate is higher. So, it will allow the transmission of different kinds of data. Broadband ISDN and ATM networks. Broadband ISDN network is a high-speed network. It supports the transmission of audio, video, text data and combinations of these data at higher rates. So it offers services such as multimedia communication, video conferencing with good resolution, multimedia documents transmission, etc. with high rates. So these networks are said to be high-speed networks because the communication medium that is being used in this network is high-quality mediums like fiber optic cables, and also it uses high-quality interconnecting devices like switches, routers, etc. Broadband ISDN networks uses transfer mode known as asynchronous transfer mode. Asynchronous transfer mode is one kind of transmission technology in which the information can be transmitted using fixed size small cells. So the broadband ISDN network, which uses asynchronous transfer mode technology, is also known as ATM networks. So ATM networks, nothing but broadband ISDN networks, which uses high-speed cables, high-quality interconnecting devices like switches, routers, etc. And other features of ATM networks are, first one is it is connection-oriented service. Before sending data to the destination machine, connection needs to be established between source and destination. Since high-quality devices will be used, switches, routers will be used, fiber optic cable being used, there are less chances of discarding data during transmission. And also there are less chances of errors during transmissions. So in this network, no attempt will be made to detect errors during transmission, and no attempt will be made to recover from errors. And also there will be no chance of occurring cells or loss of cells, so no attempt will be made retransmit the cells. ATM networks uses its own reference model. We are aware of OSI reference model. OSI reference model is a 7-layer reference model. So a lot of complexity will be there if more number of layers are present. Whereas ATM reference model consisting of only 3 layers: physical layer, ATM layer, ATM adoption layer. So the topmost layer is ATM adoption layer. In short form, we can call it as AAL layer. AAL layer gets a message from application running on the machine. So it splits a message into cells and gives the cells to its below layer, that is ATM layer. At the receiver side, AAL layer collects cells from its below layer and reassemble to form the message. Coming to ATM layer, it deals with establishment of connection between source and destination machine and release of a connection once transmission is over. So it deals with the transport of cells and network. So it will define the layout of cell. It will add header to the cell. It will get 48 payload from its above layer. It will add a 5-byte header to the 48 payload to form ATM cell, and it also performs the congestion control. The last layer is the physical layer. It deals with the physical medium. It deals with the transmission of raw bits over physical medium. The cells are being converted into, that means, a stream of bits. So the bits will be encoded into electrical signals. So the physical layer deals with the transmission of raw bits over physical medium. Coming to the ATM cell, so it is unit of data at ATM layer. So all the information it will be transported in ATM network in fixed size cells known as ATM cells. So it is 53 bytes long, 5 bytes are reserved for header fields, and remaining 48 bytes are reserved for payload field. So in header field we can find virtual path identifier, virtual circuit identifier, payload identifier, cell loss priority, header and error control, generic flow control fields. If a payload identifier field value equals to 1, then that cell is a data cell. If a payload field equals to 0, then it is not a data cell. So RM cell is a non-data cell which is used for finding and informing status to the machines. So it is also 53 bytes long. So first 5 bytes are header fields and the remaining 48 bytes for storing certain important information like a protocol ID, direction, backward notification, congestion indication, current cell rate, maximum cell rate, peak cell rate, etc. So once the congestion have been occurred in the network, the switch or destination machine will pass this RM cell back to the sender machine. So congestion is an important issue in ATM networks. Normally congestion will occur when current traffic in network is more than offered load. When current traffic at particular link or switch in a network is more than its capacity. So what will happen if a congestion have been occurred in network? The first thing is cells may be discarded without being processing. And there will be delay in delivery of messages from source to destination. And the performance of the network may decreases. Next, congestion control mechanism. To offer good network services to the users, we have to ensure that there is no loss of data packets in the network. So if state of congestion have been occurred, then we have to recover from congestion. So the congestion control mechanisms are important things in the network to provide high quality network services to the users. The congestion control mechanisms are broadly divided into two categories. One is credit based mechanism and other is rate based mechanism. In credit based mechanism, the connection will be established between sender machine and receiver machine first. Whenever sender is having more number of cells to transmit it to the destination machine, first it has to establish a connection between source and destination. So once connection has been established, then allocate enough resources at the receiving ends. So allocate resources, resources are nothing but allocate buffers at switches at the receiving ends. So the receiving end, for example, the source machine transmitting data to the receiver machine which is connected to a faraway network. In between these two machines, number of switches are there. So we have to allocate enough buffers at the first switch. So first the computer, source computer will send data to the switch first. So in this credit based mechanism, the switch will be having number of buffers. Each buffer can accommodate a number of cells. So it will send 1 credit per buffer to the sender. So credit is being considered as a permission to send a stream of cells to the next device. So once the sender gets credit, then it is allowed to transmit data to the next unit in the path. So after transmitting data cells, it will be waiting for, that means, the next credit. So as long as the credit or permission is there, the sender is allowed to send the packets. So this is the concept of credit-based congestion control mechanism. So there is no chance of occurring congestion with this scheme. So advantage with this scheme is no cell loss can be noticed, but the drawbacks are you have to allocate enough resources in advance. So the sender machine has to wait until it gets the credits or permission from the other end. So these are the merits and drawbacks with the credit-based scheme. Coming to rate-based congestion control, the sender will be sending data cells without waiting for permission or credits from other end. So delay will be less. So cell transmission rate of the source and system, it can be increased or decreased based on the status of congestion in the network. If you see in this diagram, the source machine will be sending data to the destination machine. So traffic will be there. It will also sending, that means RM cells. So the switches simply forwards data cells to the destination machine. So whenever switch identifies congestion, it places a congestion notification bit in the data cell, and it will be forwarded towards the destination. So when destination gets a data cell with EFCI bit set to 1, then it will send RM cell back to the source machine. The source machine will decrease the transmission rate. So the rate-based schemes can be classified into two categories: binary rate-based, explicit rate-based. In binary rate-based schemes, information about congestion will be indicated to the sender machine by the switch or destination machine. Upon receipt of the congestion notification by the destination machine, the sender can decrease the transmission rate, and it will be sending the data cells with the lower rates. Whereas in the case of explicit rate based scheme, information about congestion will be informed, along with the rate at which the cells to be transmitted to the destination machine will also be notified. So the examples for binary rate based scheme is EFCI scheme, whereas the examples for explicit rate based congestion control schemes are EPRCA scheme and ERICA scheme. So in this lecture, I will be presenting congestion control mechanism, namely EFCI scheme. It is very simple to implement to control the congestion. Okay, let us consider EFCI congestion control scheme for controlling congestion in ATM networks. Explicit forward congestion indication congestion control scheme. It is a binary feedback rate based scheme. It just provides the status of congestion to the sender machine. If a congestion has been occurred at a particular point in network, it may be at a switch, so that switch will set EFCI bit to 1, and it will forward to the destination machine. So the sender, upon getting RM cell, it will decreases the transmission rate. If cells are being transmitted with higher rate, so there are chances of filling the buffer with less time. So there are chances of having congestion in the network. So let us see the basic algorithm for EFCI scheme. So there are a certain number of steps in this algorithm. Step 1 is we have to establish connection between sender and destination. So identify a path between sender and destination. So identify virtual path identifier, virtual circuit identifier between these two end machines. Once connection has been identified, then specify the quality of service parameters for this connection. So the various quality of service parameters are initial cell rate, peak cell rate, maximum cell rate, minimum cell rate. So we have to specify values for these parameters at the time of establishing connection. Step 2, Once the connection has been established, then the sender can send data with the initial cell rate. So when it goes to the intermediate switch, it will accept the cells, stores the cells in the buffer. So the switch will monitor the queue length of the buffer. If queue length exceeds threshold value, then congestion is said to occur in the network. So it will set EFCI bit in the header of data cell and forward data cell to the destination machine. When destination machine gets the data cell with EFCI bit set to 1, then it will generate resource management cell, RM cell, and that RM cell will be sent back to the sender machine via intermediate switches. So RM cell, it indicates that congestion has been occurred in the network, so we have to decrease the transmission rate. Step 4, when intermediate switch receives RM cell, it simply forward the RM cell in the direction of source and machine. Step 5, when source and machine gets RM cell, it understood that congestion is going to arise within short spell at intermediate switches. So it will decrease the transmission rate. So it will decrease the allowed cell rate with the decreased rate factor. So the current cell rate or allowed cell rate value will be multiplied with the decreased cell rate. So it will be sending this cells with decreased rates towards destination machine. So it will continuously decreasing the cell rate, transmission rate towards destination machine until it gets no RM cell in the RM time interval. So when no RM cell is received within RM time interval, the source end system understood that the congestion has been relieved in the network. There is no congestion in the network. Then the source will goes on increasing the allowed cell rate by factor of increase factor. So the allowed cell rate should not be more than peak cell rate. It will be continuously increasing the allowed cell rate. So these are the steps in basic EFCI congestion control scheme. The same is illustrated by using this diagram. So you can find 4 computers, 2 switches. So 2 computers, one is a source 1, source 2, destination 1 and destination 2. So source 1 is sending data to destination 1 via switch 1 and switch 2. So switch 1 in this diagram, it is about to congest. So it will set EFCI bit to 1 and it will forward the data cell with EFCI bit set to 1 to the destination. When destination gets data cell with EFCI bit set to 1, then it generates RM cell. It will forward RM cell in backward direction to reach source machine. When source machine gets RM cell, it will decrease the transmission rate of the cells. When source machine gets no RM cell, it will goes on increasing the transmission rate of the cells. I simulated EFCI congestion control algorithm by using NIST ATM network simulator software. So we can create a computer network configuration. We can create computers, switches, applications running on computers. We can specify the link capacities. We can specify the buffer size. We can specify the parameter values. And we can run the basic EFCI algorithm with help of this simulation software. So I used the control parameters and values for parameters like this. Initial cell rate I considered 7.49 Mbps. That is, the source and machine can transmit data at this rate initially. So the data rate should not be less than minimum cell rate, that is 1.49, that I considered. Peak cell rate, that is the maximum rate at which the cells can be transmitted. So, the allowed cell rate should not exceed 149 for this configuration. Increase factor, decrease factor, I set the values as 0.0625. And whereas for the control parameters at switches 1 and 2, I considered a Q length as 1000 cells. Low threshold is 6000. So, whenever the buffer containing 6000 at that moment, it will pass as a data cell containing EFCI bit set 1. Very congested Q threshold, that is set to 900 value. So, I simulated this scheme using ATM network software, simulation software. So, I observed the results based on two parameters. One is allowed cell rate and other is percentage of cell drop at switches. So, the simulation results are presented in form of graphs for allowed cell rate versus time. So, from this graph we can show that the allowed cell rate is oscillating between initial cell rate and peak cell rate. So, it will be oscillating in that range. And also the percentage of a cell drop is there with this scheme, basis scheme. Around 13% of overall data cells that have been transmitted have been dropped actually. So, these are the drawbacks with basic EFCI scheme. So, I enhanced this EFCI scheme to get good performance. That is cell drop I want to reduce actually, and also the oscillation rate that I should control actually. So, I modified basic EFCI scheme. So, I am presenting the results in form of some graphs here. So, here the oscillation of ACR versus time have been reduced. So, allowed cell rate oscillation have been reduced up to a certain extent. Cell drop percentage is also dropped actually up to certain extent. So, if you compare the basic EFCI scheme with enhanced EFCI scheme, with basic EFCI scheme the percentage of cell drop is 13%, whereas with enhanced EFCI scheme the percentage of cell drop is 6.3%. So, enhanced EFCI scheme gives a better performance than EFCI scheme. So, the conclusion of this lecture is congestion control mechanisms are essential to get good network services from high-speed networks. So, if you have better congestion control mechanisms, you will get high throughput, high quality network services. So, I considered in this presentation EFCI scheme, but it is a simple one, but better control algorithms are available. One scheme known as ERICA scheme, explicit rate indication congestion avoidance scheme. So, I also implemented that scheme. The percentage of cell drop is around 0%. Thank you very much for watching.